everyone. How's everyone doing? Good. Cool. So this is my first time in South Africa. It's super exciting. Yeah. So also, Robert gave me a book to give away. So I'm going to crowdsource this in the sense of I really want an awesome speaker photo because I don't have one yet. So if you take an awesome photo of me and then tag me on Twitter, I'll pick the best one and then give you the book. I'm a millennial, sorry, I love social media. So, my name is Amy. I am a systems software engineer at a startup called Peptio in Seattle, United States. I also run a YouTube channel called Amy Codes, and you can find me on social media on the handle on the right, and it is at the Amy Code. So, some slides, I have things that you can Google on your own time. It'll be like a little blurb on the bottom left-hand corner. I'll also make sure to share my slides on slide deck later on Twitter. I want to kind of set the expectations for this talk. So it's very much a beginner talk in the sense of I'll talk about how to containerize something, how to get that container onto Kubernetes, and then how to package a Helm chart and version control everything. So if you are beyond that level, feel free to walk out, no worries. It is not a big deal. So let's go ahead and talk about Kubernetes. It's like my life and my livelihood right now. So in infrastructure, your main goal is to prepare for failure, right? And I have no trust in app developers, and I don't need to. And that is what I want my infrastructure to have the capacity to prepare for, right? So everything in your system needs to be able to fail, and this is where Kubernetes comes in. So if you are an application developer, let's step back for a second and ask the question, how do we get our applications into the cloud? So the core concept of the cloud is that everything is ephemeral, right? Things die, things are complicated, networks go down, and this is all in the area of distributed systems, which I love oh so much. You put a lot of trust into folks who run your infrastructure. But should you, right? So we want the services that we run on our infrastructure to be able to be available. We want to have low latency on our websites, and we want everything to just work. Downtime will cost millions of dollars, right? And we want to trust that these applications will be available. And as an application developer, a web app developer per se, or maybe mobile app developer, you don't really need to think about deploying your apps. And I'm here to tell you how that happens. So you'll think about issues like high unexpected traffic, right? Application failures, scalability, availability, and efficient resource utilization. So let's go ahead and talk about what is a container. This is very technical terminology. A container is, to me, a baby computer inside another computer, and it is that simple. So the baby computer is the container, and the other computer is your server. Why do we want a baby computer inside another computer? Again, very technical terminology. So baby computers are easy to transfer around. It's great for resource isolation, and it encompasses your application environment. And I'll go more into detail when I talk about configurations and Docker files. So a common conceptual comparison for container is to a virtual machine, but it is very different and much more efficient. And this is at the virtualization level, which you guys can all look at because I just mentioned this to you. And a container is a means to abstract away your infrastructure. So again, on the bottom left here, you can really look at what a container is by Googling keywords such as secrets and namespaces. Again, these slides will be up on Twitter. So let's go ahead and walk through our Docker file. So what I'm doing here is I'm putting an app inside my baby computer. So ignore that for a while. It's pseudo-code that I hacked up. And then here is the visual representation of what is going on. So here we have our server, and here we have a container within here. There's a lot more going on, but I'll just abstract away to this. So inside a container, what I want to run is Alpine version 3.6.2. I also want to run Python version 3.7. I have some setup scripts, and then the setup script will then deploy our app within our container. So up here you can see the Docker configuration file. Again, you can see that it's Python, Alpine. We are deploying our app from that directory, running some setup scripts, and then we're exposing port 80 to the world, and then we're running Python and then our app. So what I really want to illustrate here is that you have replicable environments, right? So you don't want to be in a situation where it's like, oh, I was able to do it on my local dev environment. How come you're not able to do it on yours, right? This way it's like repeatable, consistent, and your environment will always be the same for the applications that you deploy. So this is how we containerize something, your web app. And let's talk about putting your lovely web application that has now been containerized into the cloud. So putting the app into the cloud, our poor little baby computer is having an existential crisis. It's complicated, right? So it's asking, where should I live? So this is under the realm of scheduling. It's asking, how do I talk to other containers? So this is under the realm of networking. It's also asking, how do I talk to the world? So we can talk about routing, right? What happens if I get sick? So failure recovery. So there's a lot of things that go on that we need to be able to have some sort of platform to be able to sort of maneuver all of our containers and have this extra layer on top of that. And this is where Kubernetes comes in. Yay! Kubernetes is awesome. So Kubernetes is a container management platform, and what it all really boils down to is we have a lot of fancy abstractions to organize our baby computers. And Kubernetes is actually an open source version of Borg, which Google uses internally. Yeah, it's really awesome stuff. So if you want to Google the Borg paper, it's like pretty good. I actually felt like I learned more about Kubernetes by reading the Borg paper and seeing where the history comes in than just by reading Kubernetes docs. So that's like a good starting point for y'all. Okay, so now what we're going to do is we're going to talk about some Kubernetes abstractions. Again, just remember that these are just abstractions to organize your baby computers. So one of the main concepts is called a pod. So we just learned about containers. But on the cloud, again, everything is ephemeral. Containers can be stopped, rescheduled, and killed. And some containers are tightly coupled together in that they are dependent on one another, and therefore they need to be scheduled together on the same server. So we need more ways to organize our containers, and that's where pods come in. So what pods are that they are one scheduling unit. So there are one or more pods there are one or more containers in a pod, and each pod is given an IP address within the cluster to be reached. And you cannot reach this IP address outside of the cluster. Pods can be confusing. You rarely have more than one container within a pod. So if it's too confusing, you can just think of it as a fancy container with an IP address within your cluster. Next thing that we have is deployments. So a deployment is a grouping of pods. And here's where we bring in the idea of actual state versus desired state. So deployments, what they do is help your pods reach desired state. So you set this configuration and you say, this is what I eventually want my cluster to look like, and deployments will make sure that happens for you eventually. And it'll consolidate things if it doesn't reach that, if it's in a state where it's not that state that you've defined. But again, it's like your desired state that you want to reach. So for example, you can specify the number of pods you want running in your cluster. And the deployment controller will make sure to consolidate everything to make sure the number of pods that you want are running. So let's say you specify 3 replicas, which are 3 pods, and like one dies or you kill it, the deployment controller will make sure that the 3 pods are back up and running again. So we need more organizational concepts, and let's go ahead and talk about services. So services is another abstraction above deployments where it refers to a group of pods or deployments. So it has nothing to do with desired state, it's just a grouping. So recall that each pod gets an IP. When they restart or die or get killed, their IP can change, and therefore that IP address that you assign to a pod is unreliable. So let's say you have a grouping of pods here, front end, let's call it front end, and then you have another grouping of pods here called backend. I probably should have labeled that, but that's fine. And so they need this group of pods, they need to talk to each other and keep track of each other. And so a service defines a group of pods at a dependable endpoint, where these groupings can communicate to one another. And so for instance, in our example, we can have this group, oops, where's my mouse? This group of front end on the left here talk to the back end service on the right. So let's go ahead and talk about ingress, and then I'll pull everything together. I love diagrams. Distributed systems is a very visual thing to me, and I don't understand when people talk about distributed systems and it's just all text. It just does not make sense to me. So let's talk about ingress controllers. So this is how we bring traffic from outside the World Wide Web, the internet, inside to our cluster. So ingress, what it does is it defines how the traffic outside the cluster is routed to inside our cluster. So what it does is it routes traffic to internal services based on things like your host and your path. So for instance, if we hit the endpoint foo, it'll hit service A. If we hit the endpoint bar, service B, and so on and so forth. Okay, so let's go ahead and tie everything together. So we talked about ingress controller. What that does is it brings traffic from the internet to our ingress controller to our endpoint foo. Our endpoint foo will then route the traffic to service A. Service A will then make sure to communicate everything between our set of deployments, which is a set of pods, which contains one or more container that are coupled together, that are scheduled together within our server. So that's how everything ties together. And let's go ahead and talk about version control. Okay, so this is all wonderful and great, but how do we keep track of changes in our configuration files? So our configuration files are a set of YAML files, and we want to be able to couple every release together. So for instance, let's say we want to change image versions or a different number of replicas or a bunch of other different configuration changes for this one grouping of manifest files. We want to be able to have version control or package management somewhere in here. And this is where Helm comes in. Helm is also awesome. So what we have here is a chart, and what it does is it has some metadata to define a group of manifest files. So here we can have a chart that we call our app. It is version 1.0.0. Description that looks like a Helm chart, and the maintainer is is me. And then what this will do is it's just metadata to group together a bunch of manifest files. So on the left here is how we structure a chart. That should actually say templates instead of manifest. Sorry about that. So we are able, with this setup, to install a chart. We can list charts, we can roll them back, we can put official charts that other people wrote, we can lint out our charts. Helm is awesome. So on the top here, we have our metadata with charts that couples all of these manifest files together. And then on the right here, we can install our chart with Helm install image-demo, and then we can also list it to see that it has been installed. And I will go through the manifest files on the left here. So this is now pulling the image that we have from before into the actual manifest files to bring it to reality. So let's go back and go over this image again, because I don't want you to get confused with all the text that's about to happen. So again, we have an ingress controller, we're going to define some services, and then we're going to define some deployments. And the container that I'm going to deploy is an NGINX web server. Okay. So our end goal, oh, awesome, I do have this, cool. So our end goal, what we want to be able to do is hit the NGINX web app. So here, I'm going to call my ingress controller NGINX ingress. I'm going to hit port 4043. That's going to route traffic to our NGINX service. Our NGINX service is going to pick up some selectors. It's going to select all the pods with the label app NGINX, and it's going to route traffic to container port 80. And then we're going to see the welcome page for NGINX web server, and it's going to be awesome. It's super exciting, with a lot of text. Okay, so let's go ahead and do a little demoing. Let me X this out. Okay, pull my terminal. Oh, no. Technology is hard, y'all. It's fine. Let me see how I can exit out of this. Oh, okay. Exit. Bring in my terminal. Okay. Can you all see this? Yeah, people in the back, can I get a thumbs up? Cool. I have a little cheat sheet here to make sure I know exactly what's going on. So let's go ahead and cat out some files. I'm gonna go ahead and cat out part 1. Helm / chart. So let's go ahead and look at that. So here what we have is our chart, and we're gonna do part 1-helm, and that's gonna, we're gonna talk about version controlling our clusters. So let's do another cat, part 1-helm, and then we're gonna go inside and look at the templates. Okay, so here in our templates directory, you can see that we have our deployment file, our ingress controller, and then also our service file. So let's go ahead and do a cat of deployment. Cool. So here what we can see is we have a deployment defined, and we have 3 replicas, so that means we're going to have 3 pods. We have our label app NGINX, we have our container NGINX 1.13, I'll point that out again, it's version 1.13, and then we're going to route that to container port 80. So let's go ahead and cat out our service. So here we can see our service, and we're going to, what the selector is that it routes traffic with to the pods that have the label app NGINX. So the selector selects things. And then we're going to route traffic to port 80. Okay. So again, this is all like in the pictures that we went over. So hopefully that was helpful. And then, awesome. So what we're going to do is expose port 443, and we're going to target our service NGINX at port 80. And let's go ahead and see that this works. Awesome. So now what I'm going to do is Helm install part 1. And if everything works out, oops. Oh, sorry. I was running this demo before, so I'll go ahead and delete some things. Delete named Labradoodle. So this is like the other fun thing about Helm is that it like generates like random names for you. So I love looking at them because they're always fun. All right, and then let me do the Helm list. Oh, I forgot to like pray to the demo gods today, but that's fine. Helm delete Molten Mule. Awesome. It's like interesting imagery. Okay, cool. Okay, let's do Helm install part 1. Part 1. Cool. So what we are doing is installing our Helm chart. So what you can see here is now we have 3 containers. That termination is left over from Helm delete. And then what we're going to do is now check to make sure that we can hit up the port 443 and see our NGINX container running. So let me do an escape here. Okay. It's really hard to find my mouse. And I'm going to drag over here. Okay, So what I have here is I have my Kubernetes cluster deployed on Minikube, and so that is the IP address of Minikube. And let me show this. I mean, this is HTTPS is automatically at port 443. So this is actually hitting my cluster, and it's deploying my NGINX server within my cluster. So that's super exciting. Let's go ahead and do more demoing. So let me minimize this. Oops. And then expand this, except not all the way, because that is hard to get things. Okay. Cool. So now what I want to do is do another Helm list, and we're going to go into part 2 where we talk about Helm and their lovely values file. So Helm list again, Helm delete, giddy buffoon. Interesting. Yeah, these are always like really fun. I mean, you can name your own deployments, but like, why would you honestly? So go ahead and clear. Okay, cool. So let me do an ls. So I want to do a cat of part 2, Helm values, and then let's look at our deployment file. Templates, deployments. Cool. So here, an awesome thing about Helm is that you can actually add templating within here so that you can see like .values.scale, .values.tag, and those are all variables within my values.yaml file. So you don't want to change an entire template, right? Every time you just want to change an image version, or you want to change the replica set. There's also other things that you can change. There's like, you can add if statements within there to like flip or unflip things. You can look at that documentation within the Helm website itself. It's helm.sh. So let's go ahead and also cat out part 2 templates. Oh. And I want to do part 2 values. Oh. Oops. Sorry, let me go into that part 2 and see what's inside there. CD part 2. Okay. Cat. Values.yaml. Okay. So here what you can see is that these correlate to the values inside here. So what I'm going to define is, again, I want to have a deployment with a scale of 3, and then I want my NGINX image to be 1.13. So let me go ahead and now install part 2. So Helm install part 2. Oh, I inside that. Okay. Part 2. Okay. Cool. So now that we've installed that, let's go ahead and get our pods to show that we do indeed have 3 replicas. So kubectl get pods. So we do have 3 replicas that we defined. Now what I want to do is exec into one of these pods and make sure that my container is actually running NGINX 1.13. Let's play mouse hide and seek again. I need that thing where it's like the mouse gets bigger if you shake it. Hold on. Aha, found it. Okay, cool. There you go. So let me do kubectl exec this, and then --nginx-v. Cool. So all this is doing is it execs into our container within that pod, and then we can see that we have NGINX defined as version 1.13. Awesome. So now what I'm going to do is go ahead and list out our deployment again, so Helm list, and we're going to go ahead and change those values. So Helm list, what is the name here? Historical Dragonfly. Cool. And then what I'm going to do is do a Helm upgrade. Helm upgrade. And what I'm going to do is set our variable scale equals 9, and what we want to do is tag. So now we want to revert maybe our NGINX version to 1.12, and then I want to do this for our release of historical historical dragonfly. Hopefully I spelled that right. And then I want to do this for part 2, Helm values. Okay, cool. So what this is going to do is now set my variables and release a new, it will now upgrade our Helm release. Okay, awesome. So now you can see that there are 6 more containers running to match a replica set of 9 because originally we had 3, right? So now let's go ahead and demonstrate that we do indeed have all our NGINX containers set to 1.12. So it's kubectl get pods. All right. And then I'm going to take this one, so it's like the youngest one, and I'm going to do kubectl exec again. kubectl exec dash it, exec dash dash NGINX dash v. Cool. So now we can see all of the NGINX versions within all of our 9 pods are going to be 1.12. Cool. So now that we've upgraded, let's go back and roll back our release again. So like we don't like this, whatever this release is. This is obviously very contrived, but you can imagine how this is useful within development flow. So let's go ahead and do Helm list again. This is very tedious. So historical dragonfly. What I'm going to do is Helm, roll back, historical dash dragonfly, and we want to revert it to revision 1. So I'm going to hit 1 there. Cool. So rollback was a success. So now what I want to do is demonstrate again that we have 3 pods up and running, and now we're going to revert back to version 1.13 of NGINX. So let me do clear, kubectl get pods. Awesome. So lots of things are terminating. That's super awesome. And then let me go ahead and do kubectl exec, and then pull up. I'm going to pull up this one, it's alive. NGINX-v. Cool, so now we're back to 1.13. And let me go ahead and delete our deployment so that I can demonstrate other things. Helm, delete, historical dash dragonfly. So let's step back for a second and recognize that yes, this is very contrived, but the idea is that you're grouping together all of these versions, all of these changes together. I will demonstrate in part 3 the alternative with just kubectl and how that works out. But this is the idea of packaging your cluster together, right? So in terms of packaging your chart itself, let's go ahead and look at packaging. So Helm repo list. So what this is it's showing all the repositories that you can store your charts within. So we have the default one, which is stable Kubernetes charts, and then we also have a local one, which I will show you how to set up. So let's go ahead and do Helm search NGINX. So this is if you want to look for charts that already exist that you want to just try out, you can go ahead and look that up. And you can just go ahead and do Helm install stable / NGINX-ingress. And it's there for you because it is stored within stable. So let's go ahead and show you how to set up your chart repo locally. This is just for local development. If you actually want to set up a repo, you should actually do that, not locally. This is just local development. So let me go ahead and do, we want to package our part 1 chart. So Helm package part 1 dash Helm, and then I want to set the version to December 1.0.0. Oops. Sorry, what does that say? Let me switch file directory. What did I do wrong here? Okay. Oh, slash. Oops. what you can see here is that we have packaged our chart, and what I want to do is now move this to repository/local. So let me go ahead and move this part. Move part 1/local of Helm Chart Z to repository local. And then we do pwd. So what I want to do is now set up my environment variable Helm home equals whatever this is. And then /repository/local. Cool. And so what will now happen is when I do Helm serve, it will serve out of that repository. Hold on. Let's see. Message file or directory. Why did you do this to me? /local. Hold on. Let me see. Oh, I see. Okay, thank you so much. Okay. Let's try this. There we go. Cool. And let me go ahead and copy this value. Or actually, I don't need to do that. So now what I need to do is open up a new tab, and let me do Helm search part 1. Cool. So what that did is I registered my local Helm Chart repository, and then it went inside there to search for different packages that I have. So if I wanted to do Helm install local /part 1-helm, my NGINX cluster will then come up again. So let's go ahead into part 3, and we're going to show you what the alternative is without Helm. So, okay, let me do Helm list to make sure I have nothing up there. Cool. So let me go inside part 3. Okay. So here I have all of my separate manifest files, and I'm going to deploy each of them. So I'm going to do kubectl apply -f, go ahead and deploy the service. I'm going to go ahead and deploy my deployment, and then I'm going to go ahead and deploy my ingress controller. Okay, and then, so this in itself is already 3 commands, and the other thing that you have to recognize is that, like, if you have more, like, a lot of different kind of resources that depend on each other, for instance, if you have secrets, there's a special order that needs to happen. kubectl will, like, explode and yell at you if you do not deploy in the same order, and Helm will automatically order things for you within your templates folder. So let's go ahead and also try doing the same thing where we're setting the image and then upgrading the number of replicas. So let me do, actually let me see the state of my cluster first. So it's kubectl get pods. So remember we have 3 pods within the deployment running on version 1.13 of NGINX. So let me go ahead and do kubectl set image deployment /NGINX, and then NGINX equals 1.13. Okay, and then now I want to scale this to replicas of 9, so kubectl scale deployment replicas, typing is hard, equals 9. Oops. Scale deployment. Oh, I forgot the name. Okay, so what did I name this again? I think I named this just NGINX. Cool. So, and like, let's again step back and look at this again. So how do we version control all this, right? Like, you just sort of change these values by themselves. They're not really grouped together. So the idea of 9 replicas with 1.12 is not paired together. And there's just a lot of commands, development is slow, and the main thing is just coupling for changes. So that is why I find Helm useful in terms of package management, coupling everything together, and also it's like great for development if you just want things to work. When I just started learning Kubernetes, I had no understanding of what resources were. I just knew that these were the files that I needed to make happen and make work. I just wanted to tap on one command to deploy my cluster and make it work. And so Helm was super useful in terms of like, I was just able to run Helm install. So hopefully what you've gained from my talk is either, if you already know all this stuff, how to teach Kubernetes and how to teach like going from a web application to Kubernetes to Helm. And if you don't already know this stuff, I hope you have learned a lot. So thank you all for your time. Do you all have questions? Because I think I have about, I'm not really sure when it's supposed to end. I think 4 minutes? Yeah. Yeah.
What do you recommend for managing your actual Kubernetes cluster?
Like, what do you mean by managing?
So
your
like
actual?
using KOps or a managed service like OpenShift or...
Okay, so okay, I need to be careful about what I say. So OpenShift is interesting, right? Because for each new release of Kubernetes, right, you're not guaranteed to have the most updated upstream version. So in terms of like managed Kubernetes clusters, so kops. I'm not too familiar with kops. I've heard of Kubecorn, so give that a try maybe. Also, like AWS I think is coming out with EKS, and then also Azure, and I'm sure Google has their own thing. I don't have any recommendations because the company that I work at is very like platform agnostic in terms of like all of our tools work on everything. And we really, what I would suggest though is like really try to make sure that you keep up to date with upstream Kubernetes, whatever you're using, like whatever platform you're using. Just because there's like with each release there's like a lot of security patches. You want to make sure that like you just are always up to date and have the latest tools, right? So I'm sorry that I don't have like that great of an answer for you. I think it just depends on whatever your needs are. Yeah, thanks. Anyone else? Yeah.
Just want to know, like, do you recommend managing databases using Docker and Kubernetes?
So persistent storage and state in general is a lot of fun in Kubernetes, in the sense of it's not fun at all, because there's no state in Kubernetes, right? So usually, like, something that you can get up and running is just like use RDS, honestly. Like, yeah, like state within Kubernetes and persistent storage is something that I would like to look more into. But yeah, don't just put like your database in a pod and like hope that it'll work, because like once that pod is gone, right, then you're like you're not excited again.
Network latency, like when you're connecting multiple containers,
Mm-hmm.
instead of using NAT, the latency might be too much, right?
I'm sorry, could you repeat that?
So what about the network latency which is happening in your Kubernetes cluster? Because you're using NAT to actually route all your requests.
I don't know the answer for that, but I can talk to you afterwards. Yeah, thanks. Yeah. I'm sorry? So usually, like, I guess ingress controllers, but there's also like other load balancers that the Kubernetes community has rallied around. Trying to think of like some examples off the top of my head. I'm sorry? Yeah, but like you're saying services have load balancers? It is, but it's like I would not suggest just having a service, right, as load balancer. You probably want other things along with that. Yeah. Like you should have a controller that's load balancer and like direct traffic to your services. It doesn't have to be in REST. Right? All right. Thank you all for your time.